Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So in our previous session, we had started with the mathematical topic of class 12 called as relations and functions. There we had finished the types of relations. So empty relations is finished, universal relation is finished. These both together are called as sometimes trivial relations. So we had finished until here. So we'll be seeing these four relations in this session, and also what is function also we'll be seeing in this video. Alright, so let us start with this. So the next type of relation what we have is reflexive relation. So what is reflexive relation? So before that, okay, just we'll see what is a relation. We'll see what is reflexive relation, but before we'll see what is relation. So what is the relation, students? Relation is nothing but a subset of Cartesian product of two sets. This is called as what? This is called as a relation. Now what do we have here, students? The next type of relation which we have to know or study is reflexive relation. So reflexive means reflection, correct? So what happens, students, when you stand in front of a mirror? So when you stand in front of your mirror, your image will be formed on the mirror. Understood? So that is nothing but reflection, correct? So even in the water we can see the reflection. So if you see in the water, your image will be seen in the water too. So that is nothing but reflection. So reflexive property is very similar to that. It is just an image, that's all. So reflexive property is like this, students. Reflexive property is defined as relation R is equal to A comma B such that, okay, so reflection, right? So if A is standing in front of the mirror, what should be seen in the mirror? A only should be seen. So B should not be there. So here we will write A again. So A comma A such that A for all A belongs to A. This is called as a reflexive relation. See this? This is the definition. Okay, this is in which form, students? This is in the set builder form. Alright. So we'll take one small example. So let us take set A. Okay, so set A is equal to, we'll take 3, 6, 9, 1. Correct? This is set A. This A, whatever I've written here. So that A example I have taken. So A is equal to 3, 6, 9, 1. So now if the relation R is defined as R is equal to 3 comma 3, 6 comma 6, 9 comma 9, 1 comma 1. Understood? 3 comma 3, 6 comma 6, 9 comma 9, 1 comma 1. 4 elements are there here. For all the 4 of them, 3, 3, 6, 6, 9, 9, 1, 1. Is this reflexive? The answer is yes. This is reflexive. Why, students? Why is this reflexive? A comma A for all A belongs to A. For all the A. So A is having 4 elements, right? And all the 4 have the doublets like this. Doublets or the reflection. Whatever you put in the place of X, you will be getting the same thing in the place of Y. X comma Y. Coordinates. Okay, so this is reflexive. Considering the same example, okay, we'll take another one relation here on this side. So same example, students. A is equal to 3, 6, 9, 1. Okay. So now the relation is defined like this. R equals 3 comma 3, 6 comma 6, 9 comma 9. You can close the bracket. Now is this a reflexive relation? The answer is no. This is not a reflexive relation. Because for all A belongs to A, for all A. So this A is not being doubled there. So 1, 1 is not there, right? It is not a reflexive relation. Here 3, 6, 9, 1. Everything is there. All the elements of A is reflexive. This is a reflexive relation. Here 1 is missing out. It is not a reflexive relation. So then what are these kind of relations called as? These kind of relations are called as identity relations. So that I have not mentioned there. Anyways, okay, just make a note of this. Identity relations. So what is the meaning of identity relations? So this is how reflexive relations is defined, right? Reflexive relation is defined like this. Identity relation is defined like R equals A comma A such that A belongs to A. So what is the difference, students? Here also it is A comma A. Here also it is A comma A. Reflexive identity. Here also A belongs to A. Here also it is A belongs to A. So now what kind of relation this is? This is an identity relation. The difference here is, this is the difference. For all A belongs to A. This is only A belongs to A, that's all. So if only some or one or more elements are belonging to A and they are in this form, okay, they are called as identity relation. Okay, if all the elements of a set A are written in this form, okay, then it is called as what? A reflexive relation. Alright, so just giving the summary again. Identity relation R equals A comma A such that A belongs to A. Identity relation, students. Alright. Reflexive relation R equals A comma A such that for all A belongs to, or for all elements of A or every element of A. Anything is correct, students. Just the meaning. Or you can also write for all elements of A. Both are correct. R is equal to A comma A such that every element of A belonging to A should be in this form, or for all elements of A belongs to A. It should be in this form. So this is reflexive. And this is identity. What is the difference here? The main difference is, here every element is there. Here it is not compulsory that all the elements should be in A comma 1 comma A comma A form, or 1 comma 1 2 comma 2 3 comma 3 like that. Understood? So this is all about reflexive relation. So with reflexive relation, we have also seen one more relation that is called as an identity relation. So I defined both of them here. The next is the symmetric relation, students. Okay, we'll start with this next. Okay, symmetric. So moving on to the next one, students. The next type of relation is symmetric relations. So what is relations again? Relations is nothing but subset of a Cartesian product of two sets. That is called as relation. Same thing. What is the meaning of symmetric? Symmetric is a term which we use to define for any object if the left hand side is equal to right hand side. For example, the human face, you see this is symmetric along y-axis. So whatever is there on the left hand side is there on the right hand side as well. Is the human face symmetric along x-axis? X-axis means like this, correct? So if you cut the face like this, is the face symmetric along x-axis? It is not. Because eyes are there on the top, mouth is there in the bottom. So it must be same. So that is called as symmetric. So in relations, how is symmetric relations defined? Symmetric relations is defined like this. If R equals A1 comma A2 belongs to A. Okay, so there is one relation, a set of ordered pair, which was belonging to A, which also implies A2 comma A1 also belonging to A. If the relation is like this, okay, then we call this relation as what? A symmetric relation. So for example, so let A is equal to, same example we'll take 3691. 3691. Alright. So now R will be equal to, let us write 3 comma 6. Now if 3 comma 6 is there, so what is 3 comma 6, students? So this we will write 3 is nothing but A1, 6 is nothing but A2. If 3 comma 6 is there, then what should exist here? Comma A2 comma A1 also should exist. So that is nothing but 6 comma 3. If this is happening in a relation, then it is called as what? Symmetric relation. Understood? So this is the definition of symmetric relation. Just revising, what is a reflexive relation? Reflexive relation A comma A such that for all A belongs to A. Reflexive, symmetric, R equals A comma A belongs to A. Identity. Reflexive, symmetric, identity. There is one more relation. So in the previous slide, so symmetric is also done. So these are done. Transitive relation. So we'll be seeing about this and what is equivalence relation. And in addition to this, we have also done one more. So that is nothing but identity relation. This is also done. So now we have only two more types, transitive and equivalence. We'll be seeing transitive here only, students. All right. So what is transitive relation? So here we'll see transitive relation. So students, transitive relation. So symmetric we have seen, reflexive we have seen, identity also we have seen. Transitive also is very simple. So in a relation, if A comma B is present, if A comma B, see A and B, whatever letters I'll be writing, A, B, C, D, all these are nothing but what? All these are numbers. So instead of using the numbers, we are using what? Alphabets, that's all. So just think these are numbers only. All right. If there is, if in a relation there is A comma B, means one relation. If there is also B comma C, okay, B comma C is also there. Then if A comma C is present, this relation is called as transitive relation. Understood? If in a relation, if A comma B ordered pair is there, B comma C ordered pair is there, then if A comma C exists, then that relation is also called as what? Transitive relation. So for example, R equals 1 comma 1, 1 comma 2, close the bracket. Now see this. This is A comma B. What is A? 1. What is B? 1. This is B comma C, students. What is B? 1. What is C? 2. Does A comma C exist now? What is A comma C? A comma C is nothing but 1 comma 2. 1 comma 2 is already here. So this is called as what type of relation? Transitive relation. This is called as a transitive relation. Understood? If A comma B is there, B comma C is there, then there should exist A comma C also. A comma B, B comma C. A comma C is this only. This is only B comma C, this is only A comma C. So then this type of relation is called as what? Transitive relation. Now, sometimes what will happen, this will not exist at all. Okay, there will be A comma B, but there will be no B comma C. Okay, sometimes in relations this will not exist. Then what we can tell, even this is not existing, then also we can tell that relation is a transitive relation. Because if B comma C is not there, then how can we get A comma C? So if this is there and this is not there, okay, if this is not there, then we cannot tell that the relation is transitive. Now there is one last relation, students. What is that? That is called as the equivalence relation. So what about this? If any relation that is satisfying reflexive, symmetric and transitive. Reflexive, symmetric and transitive. So that kind of relation is called as what? Equivalence relation. Understood? So that kind of relation is called as an equivalence relation. So these are the types of relations. So after this we'll see what are functions. Okay, functions we have already seen. So just a very quick recap. In the next class we'll be seeing types of functions, students. So what is a function? So function is consisting of two parts again. So we'll see this. Okay, one small example. So this is called as mapping again now here. Mapping of function. So what is mapping of function? So all these are the set of x values. Okay, they are also called as a domain. We'll be using all these terms in our next session, students. So this is just an introduction again. Okay, on this side we'll be having another set of values. So these are nothing but y values, and these are called as codomain. This is called as image also. This is called as pre-image. Okay, see this now. Domain means x values. It's also called as pre-image. Y values, codomain, image. So what you have to do here, you have to input the numbers 1, 2, 3, 4. How are we getting the values here? But simply we cannot write 5, 6, 7, 8. Okay, this is not right. Okay, that will be a relation then. So on the right hand side, what you have to do is you have to use the function here. So what function we'll be using? So we'll be using this function. So here we'll write function x tends to y. Okay, and f of x is given as 2x. Understood? F of x is given as 2x. Means what you have to do, in the place of x, correct? This is x, correct? In the place of x, put this f of 1. In the place of x, you put 1. Here also in the place of x, you put 1 only. 2 of 1. What is 2 into 1? 2. Understood? Now in the place of x, put 2. So that will become f of 2. So that will be equal to 4. In the place of x, put 3. F of 3 is equal to 6. In the place of x, put 4. F of 4 is equal to 8. So what are all these values? 2, 4, 6, 8. So 2, 4, 6, 8. These are what, students? These are nothing but the set of y values, which is also called as codomain, which is also called as image. So 2 is the image of 1, or 1 is the pre-image of 2, like that. So how can we define now? So we can write f equals 1 comma 2, 2 comma 4, 3 comma 6, 4 comma 8. What is the one thing you have to notice? No two x values have same y value. Okay, that is called as a function. So these things are important. Okay, just make a note of them. Okay, we'll be seeing the types of functions in our next class. So until then, stay connected with V Learning, subscribe, and I'll be seeing